Welcome to the world of adding and subtracting rational expressions. Yes, it's a very exciting topic, but it's actually very cool. You can simplify ugly, ugly things down into a very nice expression. So adding and subtracting, we really have to do a little more work than multiplying and dividing, but I think it's going to be fine. You may remember back in the old days, adding nice little fractions that already have common denominators. Yeah, as in these examples, 1/5 plus 3/5 is 4/5. So the denominator stays the same, the numerators, you add them. Same with subtraction. 6/7 minus 4/7 is 2/7. Denominator stays the same, and you just subtract the numerators. Oh, we do the same thing with rational expressions, so it's not really a big deal. There's no separate set of rules or anything like that. So in this first example, we check and make sure that we have a common denominator, and we do. In this case, it's x squared minus 3. And one additional thing, we do need to identify the x values if it's going to make this thing undefined. So in order to do that, in this first example, if x squared minus 3 equals 0, then that's a problem. So we add 3 to both sides, so x squared equals 3. So when x is equal to plus or minus the square root of 3, that's going to make that undefined. So over here we can say x cannot equal plus or minus radical 3 for this particular one. So I'm just going to take this and get rid of it. We'll shrink it down. We'll put it over here in case we need it. And now we're just going to combine, because we do have that lowest, we have the common denominator. So we're going to combine this into one fraction, x squared minus 3. When we combine the numerators, I'll write it all out just for the sake of watching, for the sake of seeing it all in one place. And now you're just going to combine like terms. So we have 9x plus 4 all over x squared minus 3. And check to make sure you can't factor anything out, nothing works out, and in this case it does not. So that is our simplified expression, again with the fact that x cannot be equal to plus or minus the square root of 3. In the second example, a subtraction one, we do have a common denominator already. So again, we're going to look and say, all right, let's see what isn't going to work in the denominator. Well, 3x minus 1, if that's equal to 0, then bad things happen. So we get 3x equals 1, so x equals 1/3. So in this example, x cannot equal 1/3. I'm just going to shrink that down, slide it out of the way, in case we need it for later. So we have a common denominator, and now we're just going to simplify those into one expression. 3x minus 1 is the denominator. We have everything up top, 3x squared minus 5. Now here's the one part. You're going to be subtracting the whole thing. So you have to distribute that negative, because you're subtracting that whole expression. So 3x squared minus 5 minus 2x squared plus 3x plus 2 all over 3x minus 1. Combine all of your like terms. We end up with an x squared. We have a plus 3x. And we have a minus 3 all over 3x minus 1. And that is our final expression when we subtract those two. Pretty straightforward. So it gets a little bit trickier, obviously. If you need to find a common denominator, it just adds an additional layer of work for you, but certainly nothing that you can't handle. You may also remember this term, the whole idea of a least common multiple. So in algebra, it's still the same thing. You need to have the you have your different factors, and you want to make sure that you have the least of each one and put it together, and that makes for your simplest combination. So couple of steps, and this is right from your book, just to, so I can sort of be the middle person helping you understand what this means. You're going to factor each polynomial completely. So you're going to write it out as repeated factors. So in this case, we had x plus 3 times x plus 3, so you just write it as an x plus 3 all squared. Then when you list the different factors, if you have common factors, then you use the highest power of each one. So there's a couple of examples. So we have 4x cubed y to the 7th and 3x to the 5th y to the 4th. So if we want the smallest number that they both go into, we have a 4 in the first one, a 3 in the second, so those don't have any common factors, so we're going to need a 4 and a 3. So 4 times 3 is 12. On the expression on the left, we have 3 x's, and on the right, we have 5 x's. So if we have 5 x's, we're going to be good to go, because we have the 3 from the first one included in that. And then we have a y to the 7th and a y to the 4th. So we're going to need 7 y's. So that is the least common multiple of those two things. In the next example, we have x squared minus 4, which we can write. That's the difference of two squares. So we write the two factors that make up x squared minus 4. And then we want to factor x squared plus 5x plus 6. So we have an x, and 3 and a 2, and a plus. So those are the factors of x squared plus 5x plus 6. So we look at the first one, say, all right, well, we need an x minus 2. We know that for sure. Is there one in the second one? No. The next thing we need is a x plus 2. So we have 1 in the first one, we have 1 in the second, so we're covered. And then in the second term, we have x plus 3, which should get us there. So x minus 2 times x plus 3 times x plus 3 is the least common multiple of x squared minus 4 and x squared plus 5x plus 6. We don't need to multiply them out or anything. In fact, it's probably better to leave them in factored form in case things can simplify out and we can get rid of some things. So if you think back, when you're adding fractions, 2 over 6 plus 3 over 10, you'd need to get a common denominator before you add these two things together. So, I mean, you could go with 60 and just multiply them, but then you're going to have more simplifying when you get to the end of it. So finding the least common one will sort of minimize the amount that you may have to simplify. So in this case, 30 is the least common multiple, so you get the common denominator and then go from there. Again, nothing changes when you get to algebra. The rules are the same. So if we come to an addition and subtraction type problems here, same idea. First you want to get a common denominator and then work from there. And it's always beneficial to simplify if you can. So in this first one, we have 3x and 2x minus 2. If we factor out a 2, we have an x minus 1. In the second expression, 3x minus 2 over, factor out a 3 times x minus 1. So when we look at these two things, they already have an x minus 1 in both terms, so we don't need to do anything there. But in this first one, we're going to need to deal with that 3, and in the second, we need to deal with the 2. So if we take the first part, first term, and multiply top and bottom times 3, which is really just multiplying by 1. And then in the second, we multiply top and bottom by 2, which is really just like multiplying by 1. And we have a 3x minus 2. When we do that, we end up with 9x over 6 times x minus 1 plus, I'm just going to leave the top like that for now. see what we have to do with it, and then 6 times x minus 1. So we now have a common denominator. Given the common denominator, we do the same thing we did before. So I'm going to rewrite the top 9x plus 6x minus 4. Make sure you distribute the whole way through. Over 6 times x minus 1. Simplify that even further. We get 15x minus 4 over 6 times x minus 1. There's nothing else we can do. So as long as you keep things organized, keep things neat, step by step, things will keep getting simpler and boil yourself down to a nice little rational expression. So I'm going to leave 3b. You can work that one out on your own if you'd like. But remember, always simplify first, because if you can cancel things out, things get much nicer. And I think you're going to have a nice little cancellation in 3b. Go through that. So subtraction, same idea. I'm going to do 4b on this page as a subtraction example. So again, let's simplify anything that you can first, make life easier. So in this first one, we can factor out a 2, and we get x squared plus 32 down bottom. X minus 8 times x plus 8. And over on the second one, there's nothing to do, it's already done. So as you look at this, to get a common denominator, in the first term we have an x minus 8 times an x plus 8 in the denominator, and in the second term we only have an x plus 8, which means we're going to want to multiply this term by x minus 8 over x minus 8. So as we rewrite that, we have 2 times x squared plus 32, which may not be helpful, the way doing that one out. And then we have minus, multiply those two binomials together, we'll get x squared minus 12x plus 32 all over x minus 8 times x plus 8. So pulling that 2 out didn't really do much for us, but we'll put it back in as we go to simplify this in this next step. So we have 2x squared plus 64 minus x squared plus 12x minus 32 all over x minus 8 times x plus 8. Simplify. Yeah, we get x squared plus 12x plus 32 all over x minus 8 times x plus 8. So see if we can simplify the top at all. See if we can get that to factor. We have an x minus 8 times an x plus 8 down bottom. We have an x, we have an x. How about an 8 times 4 is 32. So the x plus 8s will cancel. And we have an x plus 4 over x minus 8 for our final solution. So that's everything you need to know about adding and subtracting rational numbers. There's one more bit, something that you'll come across, and it's about complex fractions. And the deal with complex fractions is just a fraction within a fraction, and really it's just a division problem when it comes right down to it. So for instance, in this first one, these are all examples of complex fractions. This really just means x plus 2 divided by 3 over x And as you knew from before, you simply invert and multiply. So this is an x plus 2 times x over 3, and then work things out from there. So that's really the only gig with complex fractions. Not really anything new, it's just a different way of thinking about things. All right, see you next time.